Hello everyone. We are going to do 38A, describe the preparation of 40 liters of 0.02 molar phosphate buffer, pH is 6.9, starting from a 2 molar H3PO4 solution and a 1 molar KOH solution. So one big downfall of the way I do this is that I have a program that records my screen and it only records for a limited time. And I only figured that out because I did this 4 times and it never worked. So we're going to have to do a speed run through for this, and I've already have everything all written out. So basically the pKa's you have to look up in the Gary and Grisham book, and the pKa's for these is 2.15 for the H3PO4, the H2PO4 is 7.2, and the HPO4 is 12.4. So what we know is that we have 40 liters, and we start off with 2 molar H3PO4, and our final concentration of that is 0.02 molar. We start off with also 1 molar KOH, and we're going to have and our final pH is going to be 6.9. So this is kind of what I like to call our restricting variables. So basically we're going to focus on this, and this, because this is what's restricting us, right? But this is what's restricting us the most, because we can, so the first thing we want to do is we want to figure out how much of the H3PO4 we actually need to add to get this concentration. And that's what I usually solve for first, is the concentration. And we'll show you why. So this 40 liters times 0.02 moles is basically just trying to figure out, by multiplying and crossing the units out, how much of our H3PO4 we need to add in. So we figure out that there's 0.8 moles in our 40 liters. And then we figure out how much of our actual stock solution, which is at 2 molar, to add. And we figure out that it's 0.4 liters, which is 400 milliliters H3PO4 written in the Siegel book. So the next thing to do is to always draw out this roadmap. Okay, and this is very, very important, because what you're going to do is, we know that our pH is going to be somewhere around here. What that means is there's going to be some ratio of this amount and this amount of the molecules in our solution. And there's not going to be any of this or any of this, relatively. So this is all relative and within 1%. So there's less than 1% of this, less than 1% of this, and that's because of how many logs away this is. The pKa's are from the pH. The only one that's close is 7.2. So what that means is that there is going to be, the only thing we have to calculate is what is the ratio between this molecule and this molecule at this one specific pH. At this one specific pH, there's a very specific ratio. So what I went ahead and did is I figured out that we start off with this. We still need to get here. So this is 0.8 moles, and 0.8 moles of KOH will neutralize and basically turn 0.8 moles of H3PO4 into this. So that's how much we start off with our KOH. And now what we have is 0.8 moles of H2PO4. Okay, so now we're going to set up utilizing this equation here, the Henderson-Hasselbalch, which is pH equals pKa plus log of conjugate base over conjugate acid. Basically products over reactants, right? So after doing algebra, we subtract the 7.2 and we get this. Then we raise each side, or we take base 10 of each side. And we're going to get 0.5 equals the ratio, what I wrote is just to save space, ratio between base and acid. And then cross out because I did it in pen, which is something you shouldn't do. You should always do this in pencil, but don't follow me. So this is 0.5 ratio of base to acid. And then I simply just multiplied both sides by acid, so I got 0.5 acid equals base. Then what I went ahead and did is I kind of just focused on this. I rewrote this up here. So now what we know is we know that in our total solution that we have 0.8 moles of H2PO4 or whatever we want, but some amount of that's going to be acid, some amount that could be base. But when they're added together, they're going to equal our total moles. So as you saw back here, when we figured this out, we solved for that there's going to be 0.8 moles total from the H3PO4 in order to get that molarity. So that's kind of what we solved for the how much of the H3PO4 to put in first. That way we could figure out how many moles are in there, because without this number, we would never be able to solve this. So now what we're going to do is we're going to plug in this 0.5 acid equals base into here, do some algebra 2, kind of subtract this. We're going to get, or I'm sorry, add these together, divide, and we're going to get 0.53 moles is our acid. And after re-plugging that back in, we're going to figure out that 0.27 moles of our base. So what does that mean? That means that in order to be able to have a pH of 6.9 and our total solution of 0.8, we must have 0.53 of this and 0.27 of this. Okay. And because we've already converted all of this by adding 0.8 moles of KOH, we've converted all of this into 0.8 moles of this. Now all we need to do is convert 0.27 moles of this into this in order to get the correct ratio that's going to give us this pH. And we figure out it's a 1-to-1 ratio, so it's 0.27 moles. Now we're going to add up our total KOH that we used, and that's going to give us 1.070 moles of KOH. We need to convert this into liters because they're asking for the actual volume of it. And what that means is that we're going to multiply by 1 mole over 1 liter. This is the molarity of KOH that's in our stock. And this is going to be our answer. I put this as liters. This is a L. Sorry, fellas. And this is, the book gives it in milliliters. So this is something really, really important, though. I would really suggest doing this problem over, except use different numbers. Try going backwards. Try saying, okay, well, I have this stock now, and I'm going to be adding HCl. How much HCl are you going to add to get back to here? Try thinking of this different ways. When I first did this, I did this several times over, and each time the way you're going to have to prepare for this test is taking the Siegel book and do the problems, and then change some of the variables, change the numbers, solve for different things. We have all these equations, right, for pH and stuff like that. Play around with them. Try and plug things into other things. Try and manipulate equations. Try and solve for different variables that you normally wouldn't have to solve for. And if you could do all those things, then you're going to be more than fine on the test. Okay, well, that's going to be it for today. And I'm sorry about the run through of that, but that's a very long problem and we are restricted by time. So I hope this was helpful and good luck in the future.